Hello Year 7. This is the second lesson of retrieval practice for solids, liquids and gases. Today I'm going to ask you to see if you can set up a little investigation at home. Don't panic, you don't need any scientific apparatus. This experiment is investigating puddles, of which we've had quite a number of recently. And the question I'm going to pose to you is to find out how the volume of water that evaporates from a puddle is affected by the surface area of the puddle. If you have a measuring jug in your house, this would be useful. If you don't panic, okay? We can always just look at how much volume roughly is left. You're going to need to find yourself 3 different containers, preferably a quite shallow container like a saucer, a slightly deeper container, perhaps a small bowl, and an even deeper container than that, perhaps a mug or a cup. This is going to be your independent variable. The independent variable is the variable that you change. So we are changing the type of container. The reason we're doing this is to change the surface area of the water that's in contact with the air. So if it's in a wide, shallow container like a saucer, there will be more of the surface area of the water in contact with the air compared to a tall, narrow container like a mug or a beaker that will have less of the surface area of the water exposed to the air. What we're going to measure at the end of the experiment is how much water is left. In other words, the word that we used in lesson, the volume of water that is left. This is what we call the dependent variable. So we can figure out how much water has evaporated. If we know the volume at the start and we know the volume at the end, we can work out how much has disappeared or evaporated. When water evaporates, the liquid water particles which are touching one another gain heat energy from the environment. This makes them vibrate, and as they vibrate, they start to separate from being attached to the other water particles until they turn into gas particles, water vapor particles. The final thing we will need to look at in our investigation is the control variables. Control variables are the things that we keep the same to make it a fair test. So pause the video a moment and think about what you will have to keep the same in the 3 different containers to make it a fair test. Hopefully you've come up with the initial volume of water that is in the containers needs to be the same. If we put more water into one container than another, it would not be a fair test. The other thing that we need to keep the same is the conditions that the 3 containers are left in. So we wouldn't want to put one by a window and one near the fire, because the heat from the fire would perhaps make the water particles start to evaporate faster. So they need to be kept at the same temperature, but also not near drafts. So a window, sometimes you get a little bit of a draft comes through, and drafts affect the rate of evaporation. When you think about when the acetone was dropped on the back of your hand, it felt cold because the liquid acetone takes the heat from your skin, it evaporates the liquid so it becomes gas particles of acetone, and as they evaporate, they take heat away from your body. So if there's a breeze when you're hanging up your washing in the summer, you need a bright, dry day that's quite windy, and that will dry your washing faster because the water will evaporate off the washing. If it's a damp, cold, dark day with very little sunshine, very little heat, okay, then the water vapor will not be able to evaporate off the clothes as quick and they won't dry as fast. So we've got volume of water needs to be kept the same, the temperature and the air conditions need to be kept the same for where we're going to put these 3 imaginary puddles that we're going to use in our investigation. So you will need a piece of paper and a pencil, and on your paper I want you to put the heading puddles. I want you to write the question, find out how the volume of water that evaporates from a puddle is affected by the surface area of the puddle. Pause the video to give you a chance to write this. Once you've written the question down, the next thing is to identify the independent variable. So, can you write the independent variable here is, and tell me what it was. If you're not sure, pause the video, rewind it and listen to what we said earlier. Remember, the independent is the variable that we're changing. The dependent variable, can you write that one down? Remember, the dependent variable is the one that we will be measuring at the end of the lesson. And the control variable, these will be the ones we keep the same. And I want you to identify at least 3 for me, please, that you will be keeping the same. Pause the video to give yourself a chance to write these down. So I want you to tell me what your 3 containers are, the names of them. In science, we would use something like a measuring cylinder, this is called a Petri dish, and a beaker. But you may have in your house things like a saucer or a plate. You may have a small bowl. And you may have, a large mug. Something you drink a cup of tea out of. You then got to decide on the volume of water you're going to put into these containers. Now, think very carefully. We would normally say in class, around about 10 to 20 cubic centimetres, depending on our apparatus that we're using. You don't want too much because you don't want to have to wait too long for your results, So you may need to leave these overnight to get some results. But you also don't want too little. So think very carefully about the volume that you're going to use. If you haven't got a measuring jug at home to be able to measure out very small quantities, then can I suggest something like an egg cup or something really small that you can use to measure out your volume of water to begin with. And keep this container, the egg cup, close by for when you finish your investigation once it's been left to stand. So you're going to measure out your known volume of water. You're going to pour it into each of the 3 containers. And I want you to just draw me a diagram and name me your 3 containers. So we'll call the 3 containers A, B, and C. And write down what they are, like small bowl, saucer, large mug. I want you to tell me what volume of water you put into each of the 3 containers. And the last thing I would like you to do is I want you to take a ruler and I want you to measure the diameter, the width, of each of these fake puddle surfaces. So I want to know the diameter in centimetres. What is it for your small bowl? I want to know what the diameter is for your saucer or plate, whatever you've used here. And I want to know what your diameter is for your narrowest puddle, which is your large mug. It could be a jug, it could be anything you want. So make sure you've written down what the volume of water is in each. So say you were going to put 10 cubic centimetres of water, or you could write millilitres, by the way. Some measuring jugs at home will have millilitres on the side of them. I'm going to write underneath that I've got 10 cubic centimetres in each of my containers. Then I need you to leave them, until perhaps either this afternoon or tomorrow, and go back, and if you've got a measuring jug, I want you to measure what's left. So there might be, let's say 3 cubic centimetres left in my saucer. There might be, let's say 7 cubic centimetres left in this one, and there might be 8 cubic centimetres left in this one. So this tells us how much water was left. So this would be the volume of water left. So that's the volume at the start. That's the volume of the water left. So then we want to know what was the volume of water that evaporated. So if there were 10 to begin with and 7 was left, how much has evaporated? 10 minus 7 should give us 3 cubic centimetres. If there were 10 at the beginning and only 3 was left at the end, 10 minus 3 gives us 7 cubic centimetres that have evaporated. And in our large mug or jug here, if there were 10 at the beginning and 8 were left at the end, then only 2 had evaporated. So we're going to write a conclusion from your results that you get. And pause the video, make sure that you've written down all of the information on your sheet of paper. And again, we're going to keep these sheets of paper so that you can show your work when you return to school. And in here, we would have our independent variables. So this is going to be our container. So you will need to put the names of your container. There are no units because this variable is a continuous variable. This variable, the dependent, is the volume of water that evaporated. So how much has gone in centimetres cubed. And it does have units, centimetres cubed or millilitres, as I said before. Now you could also, to make this even better, this investigation, put in the additional information that I asked you to measure, which was the diameter of the container. Now the reason why this will make your investigation even better, knowing the diameter of the container, is this variable is a continuous variable. So is this one. They're both numbers. When we have two continuous variables, we can link them together. For example, we could say that as the diameter of the container gets bigger, in other words, as the dish is wider, there's more volume of water that evaporates because more of the surface area of the water is in contact with the air particles. And the air particles will warm up the water particles and cause them to start to move and evaporate, release from the bonds that they are attached to one another. So when you've filled in your table for your results, and if you haven't got any results, if you can't get any, we can always use these ones that I've got. So I've got A was my small bowl. And that had the volume of water that evaporated in that one was 3. So we've got 3, 7 and 8. This was our mug and this one was our saucer. And I'm going to give you some imaginary surface, or not surfaces, but imaginary diameters. So our small bowl is going to be, let's say, 7 centimetres wide. Our saucer is going to be 15 centimetres wide. And our mug is going to be, it's going to be a very narrow mug, 5 centimetres wide. Have we got those volumes right? Small bowl, let's just check. 372. Oh, I knew I had that one wrong. Oh. Let's get the rubber. And that one should be 2 volume. Okay, so see if you can write a conclusion, what you found out in terms of how much volume of water evaporated. Can you compare it to the size of the container, or the diameter of the container would be even better, and explain to me why this happens. You might want to use particles, heat energy, changes of state, so starting to go from a liquid to a gas, and evaporate is a definite key word here. So from liquid to gas. Now the next task I'm going to set you, we're going to skip a few pages in here because it talks about calculating the area of a circle using pi. So we'll come back to that at a later date. We're going to look at these results here in this slide. So it says this person collected some data. They had equal amounts of water in 4 sources. They used hairdryers to make the wind. To give the different speeds of wind across the water, they put the hairdryer nozzle at different distances away from the saucer. And to give different temperature winds, they used the cool or the hot settings on the hairdryer. So this is what they did to the 4 saucers. Saucer 1 was away from the drafts at the side of the lab. Saucer 2 was on the hot setting of the hairdryer 30 centimetres away. Saucer 3 was on the cool setting 50 centimetres away, and saucer 4 was on the cool setting 30 centimetres away. This is what they found out. The time it took for 20 drops of water to dry up. The longest was 3 days in saucer 1. Then the next was saucer 3. Then saucer 4. And the fastest was saucer 2. What do the results in saucers 3 and 4 tell you? So look at these 2 saucers. What have they got that's the same? They're both on the cool setting for the hairdryer. Which saucer had the wind from the hairdryer the furthest away? Saucer 3. So if we look at saucer 3 and saucer 4, which one took the longest for the 20 drops of water to dry up? Why is that? Look at saucers 2 and 4. Saucer 2 was on the hot setting, saucer 4 was on the cool setting, but they both had the hairdryer the same distance away. So the wind setting was the same, but the temperature setting was different. Which one evaporated fastest, 2 or 4? Why is that? What I would like you to do is I want you to write a letter to these scientists to summarise what they have found out. In your letter, you will need to write, "Dear scientists, we have found out that the results in sources 3 and 4 tell us," and you're going to finish that bit off. So I want to know what the similarities are, what the difference is, and what the results tell us about sources 3 and 4. Then the next sentence, very similar. We have found out that the results in rather than sources 3 and 4, the sources in 2 and 4 tell us. And again, I want you to tell me what's the same in sources 2 and 4 and what's different and why the results are different in sources 2 and 4. So in other words, we're summarising what we have found out from these scientists' data. In your letter, don't forget to tell me what was their independent variable. Now this time, it's different to the one that we did in our puddles investigation. What were they changing? What was their dependent variable? Again, this was different in their investigation. What were they measuring? And what were their control variables? What they were keeping the same to make it a fair test. So include all of that in your letter, and then don't forget to sign your letter off. Yours faithfully, and then put your name. Okay. Make sure you keep that letter along with all your other classwork for these retrieval practice tasks inside your books, and we will see you back in school hopefully soon. Thank you.